So thank you for inviting me. I'm not an expert in loudness, and actually this presentation for me will be to learn a lot from what you have to say. And this project has been in collaboration with a lot of people, and I just was the one maybe to analyze the results and to bring some expertise on the visual field. I'm recording the presentation, but I will cut on the discussion, so you are free to say whatever you want. And I will probably upload it on YouTube, so if you want to share later or this thing. The presentation is on my webpage, also you can find it there. So the problem that we are addressing is that the hearing aid users complain that it's too loud sometimes, and the clinical audiological methods, they don't really reflect what's happening in the field. And this paper here talks about loudness discomfort level, and that they are not reflecting what is happening in the field. So a bit of related work. Carolina did a study about loudness in the field in the laboratory, and they were adjusting their setup. They actually found out that in the laboratory people preferred less than normal loudness levels on the hearing aids. So there's already a difference on the hearing aid preference in the field and in the lab. And actually this is very famous from Hugo Fast, that if you see a red train, for example, it sounds louder than a green train. So, and also that if you see visual cues, usually sounds are perceived less loud. So there are a lot of indications that visual cues should be included in loudness perception. So this is a bit the question: what do we need in the laboratory? Do we need immersive setups, virtual reality, 3D audio with 96 loudspeakers? What is necessary to achieve the same results as in the field? So the method that we're using here is we're using vehicle noise in the field, and then we are recording this vehicle noise, and then we are putting it in the laboratory, and we are testing different conditions in the laboratory. So this is a bit an overview of the project. So you have we had some people sitting down on some vehicles going by, and put the faces for anonymity reasons. And I'm going to be talking about the normal hearing participants. I didn't analyze all the data, and there are still 5 participants missing. And basically we collected loudness and annoyance, and there were tests and retests in these situations, but I will show later. This is just an overview so you can get. So these are the vehicles that we use. We use a fairly new Opel Corsa, motorbike, van, and a street sweeper. And we recorded this with an ambisonics microphone and a 360-degree camera. And the videos of the stimuli can be found here on my webpage, so you can also use them if you want to do this experiment in your laboratory. You can also test different conditions, and I will try to upload all the material because now it's only 360 and XY microphone, but I will try to upload also the first order ambisonics recordings. And this is the lab setup. So we had 3 lab setups. We had mono and no audio, and then we have the screen and stereo, and the head-mounted display and stereo. So these are the three conditions that are fairly easy to set up in a laboratory, not very complex, so that we can achieve. And these are the driving actions. So basically the participants were sitting here, they were the recording devices on the middle, and the vehicles were going from left to right, and they were these are urban actions. So standing by with the engine on, accelerating at 30 kilometers per hour, 50 kilometers per hour, and braking and stopping. And then we had also the street sweeper, which was a very nice addition because it made a really loud noise when it was cleaning the floor, and actually got to 90 dB or the SPL or even more. And in total there were 36 driving actions. This is the scale. Probably you are familiar with this. So this is the categorical units. They rate this from not heard to very loud, and this is the annoyance, so from 0 to 10. And this I'm going to be talking a lot about. These categorical units is the measure I'm going to be showing on the left side, and they are shown in numbers. So it's important to remember that CUs are these values here. So the field results are just a collection of the ratings that they did, and I compared these to some loudness models and transformation functions from zones to the ratings on categorical units. It would look, well, this is the variability of the ratings, so you can see that, sometimes they went to middle to loud in the same object, so there's a lot of, I think there's quite a bit of jumps between these, but they follow more or less the same line. This is the subject, so they rated twice the same action in the test and retest. these are the results. So here you can see the colors of the vehicles. So you can see that the car, for example, was less loud, and here you have like the street sweeper here on the top that reaches quite high levels. I use the zones, and these are the curves that the literature would predict. So and these curves were done in the laboratory, so there's a bit of an indication that actually the ratings were softer in the field than in the laboratory. But I will talk about this because there's a discussion about this figure also. Okay. And the laboratory results, we only did 10 participants, so this is on normal hearing and a bit more 20 on hearing impaired. And I'm going to be showing the ones from the normal hearing. So this is the curves that we got from the stereo and the audio mono, so with the screen and without the screen and mono, and the curves are quite similar. So you can see that actually you get the same results. This is from the field and the head-mounted display. So this is the line I showed before, this red line. And then we have the head-mounted display that approaches this more or less the same levels, about 40 zones. And here, actually, people rated it to be lower. So it's a bit surprising. And then if you put all together, so it's a bit confusing, I know, and there's a lot of standard deviation. This is why I didn't want to spend too much time on this slide, because you can see that the standard deviation is very high and that the ratings are crossing. But my colleagues told me that there might be an interaction effect here. So for lower sounds, it's perceived higher in the field than with the head-mounted display, and that for louder sounds, people actually rate louder in the lab than actually in the field or with the head-mounted display. So this is an indication. It's only 10 subjects, and it's in this experiment, so it's not an overall conclusion. And actually, this is important that the participants covered from very soft to loud. So they cover the whole scale. And actually, what would have happened if we would have used a bike, for example? I think that all these ratings would have been much higher. So this is also important, that we use vehicles and we then use a bike or a skateboard or somebody walking, and then there would be this limit here of the very soft or not heard. And these individual differences between the ratings that they did in the lab and the field. So the action that they rated in the field was subtracted. So for example, if the car was stopped, then I check what is the difference between the rating they did in the field and the rating they did for this action in the laboratory. And these are the results for the three. And you can see there's a lot of variation on the CO ratings. And then maybe there's a slight, so that it's perceived louder with the screen and stereo and the audio-only mono. And the head-mounted display gets a bit closer results. And what is interesting, I was glad, because when I found this result, I was really disappointed, because there's a lot of standard deviation, probably it's not significant, and it's like, okay, what's happening here? Does it make a difference? Actually, if I would see this picture, I would say, no, it doesn't make a difference to measure it in the lab with mono, and to make a huge experiment renting a street and measuring vehicle noise. But actually, the individuals have different lab effects. So it's not that everybody is in the same line. There's actually some people that the lab effects are higher. So always here, like louder, like above 0 means louder in the lab. So there's actually a group of people that they perceive that it was louder in the lab. And if we see this across the conditions, these people are quite consistent. So it doesn't matter if they're using the head-mounted display or the screen or audio only. So they actually, there's maybe this guy here, this person here, that with the head-mounted display had lower ratings. And if you look there, here with the audio only, this number 6, here perceived louder, but then here also, but in the audio only not. So, I mean, there's a tendency, but it doesn't work for everybody. And just to prove this point, I put also the data from the hearing-impaired subjects. So here you can see that with 29 subjects, you have like this, a lot of people here. And actually, there's people that the loudness perception was lower in the laboratory, so they thought it was less loud. So for conclusions, I would say that more realism immersion gets closer to the field results, at least what the graphics were showing. Maybe it's not significant because there was a lot of deviation, and that the effects of the laboratory are individual, and that the loudness models and transformation functions are not predictive in this case, but that really depends on what you use. So that would be the end of my presentation. Thank you very much.